In this session, we try to understand what are logical operators. So in the previous session, we have seen how relational operators are used to compare two different values. So relational operators results in a Boolean value, right? It either gives it true or false. But in some situations, we have to combine more than one condition in order to get output or in order to perform a particular task. So in that case, how do you basically take a decision? Let's take an example. Suppose you want to go to a place from point A to point B. Now, how do you basically choose the way how you want to go? There might be different constraints that you'll consider here, right? So example, I want to take the route which is less in distance, or I want to take a route which is less in traffic, or I want to take a route which is having both of these conditions or either of these conditions. So there could be some situations where you need to take a decision considering more than one constraint. So what do you mean by one constraint? It more than one condition. So if you want to combine more than one condition, then we have to use logical operators. So Java basically supports three types of logical operators: logical AND, logical or logical NOT. So first let us see how logical AND will work. So all these three are used to combine more than one constraint, but each one will be used for a different context. So let us understand how logical AND will be used programmatically.
Hey, thanks for watching our content so far. If you're new to Training Mark, we're the fastest growing technology training company and create content to help freshers like you to master the disruptive technologies like full stack development, AML, cloud, DevOps, etc. If you like the content so far, please subscribe to our channel and hit the bell icon not to miss any new content from us. Like and share this video with all your friends. Let's build your career and the community together.
To demonstrate logical AND, I'm just right clicking here, selecting a new Java class, and then say this as logical operators. Now let me write the main method and then write some description about logical operators. So first and foremost, logical operators are used to combine more than one condition or constraint or expression. So what do you mean by an expression? Example, suppose you have an expression A greater than B, or this is called one expression or one constraint or one condition. You want to combine it another one, so then you have to use a logical operator, right? So like that you'll have a combination or combine more than one condition or a constraint, we have to use logical operators. So the first and foremost we use is logical AND. Okay, it just simply performs like AND gate. So there is a particular rule for defining logical AND, or how do you evaluate logical AND. So syntactically, if you look at logical AND, so suppose I'm just calling this as an expression 1 or constraint 1. So we use these two ampersands to define logical AND. Now expression 2 logical AND, expression 3 logical AND, expression 4. So what is this each expression? Each expression is nothing but one relational operator functionality, like A greater than B. So you're doing one relational operator here, right? So this is basically called as one condition or one expression. So like this you will combine more than one expression to figure out how logical AND will be done. So now how this will be evaluated is basically defined by a rule. So what is the rule of a logical AND is, the rule of a logical AND, or how it will be evaluated is, if any one of the expression is false, then the entire resultant is false. So what do you mean by that is, suppose while you evaluating expression 1, so how it will be evaluated? First expression 1 will be evaluated, so something like A greater than B, which will give you true or false. Like expression 2, true or false. Expression 3, true or false. Like that, true or false and true or false and or something like that, you'll have it, right? So if any one of this expression is evaluated to false, then the entire resultant is false. So that is what how logical AND will be evaluated. So there is a truth table to represent how logical AND will work. Example, first expression is evaluated to true, second evaluation is evaluated to true, then the resultant is true, because 2 and true will give you true. Then okay, so let me write it in multiple line comments. Okay, so now here, so true and false, the second expression, which the resultant is going to be false because the second expression is false, and false and true will give you false, and false also give you false. So like that, the truth table of logical AND will be like this. So let us see with a simple example. Suppose I'm just taking byte number 1 comma number 2. I'll just say number 1 is equal to some 100, and then number 2 is equal to some 120, right? So now how do I check the comparison between these two, right? Or maybe to take a real-time example, so what I do here is I'll just take byte distance, right, is equal to some value, let's take 100, and then let's say time. Okay, so now I'm just going to say time equals to some 5 hours or something like that. So now how do I do this? So with a logical AND, right? So now I'll just try to compare with SOUT, right? I will just write it something like this. The first expression which I'm writing is distance is greater than 50. Okay, so I'm just checking this value. Logical AND time is less than 5. So let us say that how I am comparing this, right? So now I'm checking two conditions. Distance is greater than 50 and time is less than 5. So then the condition will be, if both of these conditions are true, then it will be true, or if any one of these evaluated to false, then the resultant is false. So if you evaluate this, 100 is greater than 50 is true, whereas time less than 5 is going to be false, or maybe less than 2 also. So then this is going to be false. So what actually happened here is the resultant is going to be false. So now let me run this. So when I run this, now you see the resultant is false. Why? Because this is true and this is false. Now I'll check if the distance is greater than 500. Now what basically happens now? Now this will become false and this is also false. False and false is going to give you false, right? So now this is also false. So like this, the logical AND always will evaluate based on this truth table. You can have a number of logical ANDs, but if any one of the evaluation is if any one of the expression is evaluated to false, then the entire resultant is false. Now let us understand logical OR, right? So now logical OR. So what logical OR is used to? Now, this is also used to combine more than one expression, but it is represented with two pipe symbol. So this is what is the symbol, okay, which is above your enter key on your keyboard. So this is what is a pipe symbol. So two pipe symbols will use for logical OR. Or if you look at the expression, this is expression 1 logical OR, expression 2 logical OR, expression 3 logical OR, and so on. You can combine n number of expressions. Now how this will be evaluated? So again you will have a rule for logical OR is, if any one of the expression, if any one of the expression is true, then the entire resultant is true. This just works opposite to AND. So any one of the expression is true, then the entire resultant is true, right? So now let us see with the example. So I'm just using a SOUT. Now let me take the same thing, okay? So now it will just take either of the condition is true, then it is to be true. So it's very simple. Either of the condition should be true. This is both the condition should be true. That is what is basically the difference. So you'll use logical AND if your requirement is all the condition must be true, then you'll take the call. Or if any one of the condition is true, then you want to take the call. So depending upon that, you might use logical AND or logical OR. So now here I'm just using this logical OR. So now you can see this distance, which is 100 is greater than 500. This is false. Whereas time less than 2, this is also false. So false and false will give you false. So now what I do, I'm just changing this is to greater than 2. Now this is true, now this is false. So the resultant should be give me true. See, this is true. So now even in the same case, now if you can do greater than, the first one is going to give you false because the first one is false. So when you run this, so you can see false and true. So like this, you'll have a logical OR. So what is the truth table for the logical OR? The truth table for the logical OR is, so first true and true will give you true, and true and false will give you true because one of the expression is evaluated to true, so then it is going to give you true. So then this is going to be true and this is going to be false, right? So this what is logical OR. And then you have a third logical operator which is called as logical NOT or logical XOR, sorry. So what is this logical XOR? Is it will be used with this symbol. Okay, so now it is also will be used something like this: expression 1, expression 2, expression 3, so on. So now how this logical XOR will be evaluated? So the rule is, if both the expressions are evaluated to the same output, then the resultant is false. So what do you mean by this? See, is if both the expressions are evaluated to the same output, example expression 1 is true, expression 2 is true, then this will evaluated to false or something like that. Now let us see the truth table first. So now true and true will give you false, and false and true will give you true, and true and false is going to give you true, and false is going to give you false. So this is what is a logical XOR. We don't use logical XOR much, but we use only logical AND and logical OR, either in both the situations or either of the situations. So but now let us see this just to see how logical XOR will work. I'm just changing this to logical XOR and save this. The first one is false, second one is true. False and true will give you true. So let me run this. So now we got this true. So like this you can evaluate by changing these values to see how logical operators will